label the first node at depth LX1 as code word 1. And eliminate descendants. Then label the second node, label the first remaining node at depth LX2 as code word 2 and eliminate descendants. And so on. And because these lengths satisfy the Kraft inequality, it must be true that we can perform such a construction. It must be true that there will be enough leaves in the graph that this will work. So for example, before I had my code, this was the tree. So my lengths were 1, 2, and 2. Let's verify that these satisfy the Kraft inequality. So my set U was binary. So cardinality of U is 2. So these satisfy the Kraft inequality. Show by saying the sum over x of cardinality of u to the minus L of x is equal to, okay, we have 3 letters, 3 letters, one has length 1, one has length 2, and one has length 2. So I have 2 to the minus 1 plus 2 to the minus 2 plus 2 to the minus 2 has to be less than or equal to 1. And this is 1/2 plus 1/4 plus 1/4, which is equal to 1, and 1 is less than or equal to 1. So indeed, these lengths do satisfy the Kraft inequality. So, following this construction, how do we construct a prefix code using these lengths? Well, here's my tree of size 2. So what I'm going to do is I'm going to take LX1, I'm going to take the length of the first code word, which is 1, and I'm going to find the first node at depth LX1. It doesn't really matter what direction I go in. I can start on the right or the left as long as I'm consistent. I'll start on the left. So there's the first node at depth 1. So I'm going to eliminate its descendants. So there's my first code word. My next code word, find the first node at depth 2. There's the first node of depth 2, so that's my next code word. So my code words are 0, 1, 0, and my third is there, 1, 1. I don't have to do it this way. I could say, I don't have to do it in this order. Let's say I have 2, 1, 2. It still works. How would that code work? I would have, here's my tree, 0, 1, 0, 1, 0, 1. What's my first code word of length 2? What's the first leaf at depth 2? 0, 0. There are no descendants to eliminate. Okay. what's my first remaining, that rules this guy out, by the way. What's my first remaining node at depth 1? So it has to be 1. So I can't use this guy because he's already part of a code word. So therefore I have this. And eliminate descendants. And what is my last remaining code word? Of length 2. It's 0, 1. So that's also a prefix code. No code is the prefix of any other. Yes?
Could you repeat the part? When you said we remove this, you remove the 1 after 0 because it's a descendant?
Yes.
But you use it again at the last 0, 1?
Oh, so I mean, I can't use this node as a code word because it's the prefix of a code word.
Only 0 by itself?
Yes.
Okay.
That's right. So in other words, this is ruled out as a code word.
Oh, but you didn't prune the tree.
That's right.
Okay.
That's right. All right. So the optimization problem now becomes